Dear friends, in the last lecture we have discussed about the concept of linked list and its advantages over arrays. We have also discussed the traversal and search operation on one-way linked list. Now we continue our discussion with insertion and deletion operation on one-way linked list. Before continuing insertion and deletion operation on linked list, it is essential to clear the concept of memory allocation and memory deallocation. You all know that linked list is dynamic data structure, that is, the size of linked list can be increased or decreased at runtime. Here, increasing the size of linked list means adding a node into the linked list, and decreasing the size of linked list means removing a node from the linked list. As linked list is the collection of nodes and inserting an element into the linked list means inserting a node. Therefore, to insert an element into the linked list, the first requirement is to get a free node. Getting the free node for insertion is known as memory allocation. This memory for the node is allocated to linked list by the operating system, which maintains the pool of free memory space. Operating system maintains this pool of free memory and allocate the required memory to any requesting process. As we have seen in the program code in previous lecture, this memory can be taken from this memory pool using malloc function. This function is used for memory allocation in language C. C++ language use new operator for allocation of memory for the node to the linked list. Other languages use other syntax. Similarly, in case of deletion of a node from the linked list, it is desirable to return the memory taken by deleted node to the free memory pool. This returned memory may be used for other processes. Returning the spare memory which is not required is known as deallocation operation. To deallocate memory to the free memory pool, free function is used in language C. C++ uses delete operator to deallocate memory to free memory pool. Other languages use different syntax. It is always advisable to deallocate memory that is not required. Let us start with the insertion operation on one-way linked list. While inserting an element into a linked list, the first requirement is to get a free node from free storage list. Once space for new node becomes available, the element to be inserted is placed into the info part of new node and pointers are set to add new node at the desired insertion position of the linked list. Desired position of new node may be at the beginning of linked list, may be at the end of the linked list, or at any position between first and last node of the linked list. Insertion at the beginning of the linked list. Let us discuss the insertion of new node at the beginning of the linked list. While inserting a new node at the beginning of linked list, first of all we need to check whether linked list is initially empty or not. Look at this diagram. If the linked list is initially empty, then we will store the null value in the next part of new node which is to be inserted. This is because initially the linked list is empty and after insertion of new node, it will become the first and last node, and we know the next part of last node contains null. As this new node is going to be the first node, so the address of this node will be stored into list pointer variable begin as shown here. But if the linked list contains one or more nodes, then the address of first node will be stored into next part of new node and the address of new node will be stored into list pointer variable begin. Look at this diagram. Here initially the linked list has 4 nodes. A new node will be inserted as the first node. So, the next part of node new will have address of node 5. The list pointer variable begin will hold the address of new node 3. Insertion at the end of linked list. To insert a node at the end of linked list, we have to traverse the list to reach at the last node. Once the address of last node is obtained, it is easy to insert new node, as the new node is to be inserted at the end. So, the next part of new node will have null indicating last node. To have proper understanding, look at this diagram. The next part of node new will have null, as after insertion this node will be the last node, and you know the next part of last node always contains null. Here the address of last node is pointer that can be obtained by traversing the linked list. The null value in the next part of last node is set to address of node new. Insertion at a particular position of linked list. Let us discuss the insertion of new node after a particular node in the linked list. To insert new node after a particular node, the first step is to locate the address or position of a node after which we want to insert the new node. Two cases arise. First, the desired node is found in the linked list and the new node will be inserted after it. Second, the desired position is not found in the given linked list and the insertion of new node is denied. To understand the concept of insertion of a new node after a particular node in the linked list, consider the diagram. Suppose we want to insert new node after the node containing element 12. The first step is to traverse the linked list to find the address of node that contains element 12. Here we have found the address of node 12 as pointer. Now, next part of node new is set to address of next part of node pointer. As shown in this figure, the news next will have null, as it will be the last node after insertion. The next part of node pointer will have address of node new. Consider another example where we want to insert new node after the node containing element 7. Look at this figure here. New node is required to be inserted after node containing element 7. The first step is to traverse the linked list to find the address of node that contains element 7. Here we have found the address of node 7 in variable pointer as shown in the figure. Now, next part of node new is set to address of next part of node pointer. As shown in the figure, the news next will have the address of node 12. the next part of node pointer will have address of node new. Deletion from the linked list. Now, let us discuss the deletion of a node from linked list. Once the node is deleted, the memory held by deleted node must be deallocated, which may be used by some other process. The deletion operation can also be performed at the beginning of the linked list, at the end of the linked list, or deleting a particular node in the linked list. Let us discuss the deletion process. Let us have a look at the deletion of a node at the beginning of the list. As we have to delete the first node of the linked list, so it is a very simple operation. After deletion of first node, the list pointer variable begin will point to second node of the linked list. The space occupied by deleted node is returned to free storage list. Look at this figure. Here, the first node of the linked list is to be deleted. Firstly, store the address of first node in a pointer variable, say pause. Then the list pointer variable begin is set to address of second node. Here the variable begin will have address of node 8. At this stage, the node 5 is not the part of the linked list and it is deallocated as the address of this node is in variable pause. Now, let us discuss the deletion of last node. For deleting the last node from the linked list, it is necessary to traverse the linked list for finding the address of second last node. Yes, we are to get the address of node preceding the node to be deleted. Here we are to delete the last node, so we need the address of second last node. The next part of second last node is set to null as it will be the last node after deletion. Look at this diagram. Here in this linked list we want to delete the node 12. We traverse the linked list to find the address of second last node. Here we get the address of second last node in variable pointer 1. We also store the address of last node in variable pointer 2. Pointer 2 can be got by taking pointer 1's next. Now, the next part of pointer 1, that is next part of second last node, is set to null as it will be the last node, and the deleted node 12 whose address is in pointer 2 is deallocated. In case linked list has only one node, then after deletion of this node, linked list will become empty and the deleted node is deallocated. This case of deletion is shown here. Here the linked list has only one node. The address of this only node is in variable begin. We deallocate this node first and then the variable begin is set to value null, indicating empty linked list. Let us come to most general case of deleting a particular node. Here the desired node to be deleted may be the first node, may be the last node, or any node between first or last node. If desired element is first node or the last node, then the case of deletion is simple as discussed in previous section. But if the desired node is in between the first node and the last node, then we need address of two nodes. One, the address of desired node to be deleted, and other, the address of node preceding the desired node. To accomplish this task, the linked list is traversed from beginning and compare the element in each node with the desired element that we want to delete. Two pointer variables, pointer 1 and pointer 2, are used while traversing the list for locating the address of desired node to be deleted and its preceding node. To understand the concept, look at this figure. Here is the linked list with 5 nodes, and suppose we want to delete the node containing element 42. Here it is the 4th node. To delete node 42, we traverse the linked list to find the address of node 8, which is preceding the node 42, and address of node 42. Here the address of node 8 is pointer 1 and address of desired node 42 is pointer 2. Now, it is very simple to delete node 42 from the linked list. Just change the next part of node 8. Here we change the value of next part of node pointer 1 to address of node 32, which is in the next part of node 42. That is, we perform the operation pointer 1's next is equal to pointer 2's next, as shown here. Now, the node 42 addressed by pointer 2 is not the part of the linked list and hence can be deallocated for the use by some other process. If desired node comes out to be the last node, even then same steps will be followed to delete the last node. Consider the following linked list in which we want to delete the node containing element 32. Here we are to delete the last node. So, the linked list is traversed to get the address of second last node and the last node, and we get the address of node 42 in variable pointer 1 and address of desired node in variable pointer 2. Now, just perform the operation pointer 1's next is equal to pointer 2's next to store the null value into the next part of second last node. This is because pointer 2 next is null as it is the last node. In case desired node to be deleted is first node, then it is deleted just like deleting the first node of the linked list as discussed in previous section. So, consider the linked list in which we want to delete the node containing element 25. Here, while traversing, the desired node to be deleted is found as first node. So, to delete this node, the first step is to store the address of first node in a variable. Here, we store the address of first node in variable pos by using pos is equal to begin. Now, list pointer variable begin is set to address of second node, which is 17. Here we use begin is equal to begins next. At last, deallocate the memory held by node pos. So, we are done with the concept of traversal, searching, insertion, deletion operation in one-way linked list. Now, we turn to second type of linked list known as circular linked list. A circular linked list is a list in which last node points back to the first node instead of containing null. The circular linked list can be shown diagrammatically as here the linked list contains 5 nodes. The next part of last node holds the address of first node instead of null, as is the case in one-way linked list. Circular linked list does not hold null value in any node. All the operations which can be performed on ordinary singular linked list can easily be performed on circular linked list with a few changes. In case of one-way linked list, the next part of last node contains null, but in case of circular linked list, the next part of last node contains address of first node, which is begin. Thus, for reaching at the end of circular linked list, we will compare the address of first node, that is begin, with the address stored in next part of each node. If both the addresses comes out to be same, then we have reached at the end of circular linked list. Secondly, when a new node is to be inserted at the end of circular linked list, its next part will contain the address of first node instead of null. Here is an example to explain the insertion of a node at the beginning of circular linked list. Consider the following figure. Here in this figure, the node new is to be inserted at the beginning of linked list. To insert this node at the beginning, the following operations will take place. The dotted lines show the new links. First, the next part of node new will hold the address of first node of the linked list, that is news next is equal to begin. Second, the next part of last node of the linked list will hold the address of node new, which is to be inserted. Here pointer is the address of last node. So, pointers next is equal to new. Third, the pointer variable begin will hold the address of node new, that is begin is equal to new. Here is another example for insertion of new node at the end of linked list. Here in this figure, the node new is to be inserted at the end of linked list. To insert this node at the end, the following operations will take place. The dotted lines are the new links. First, the next part of node new will hold the address of first node of the linked list. Here news next is equal to begin. Second, the next part of last node of the linked list will hold the address new, the address of last node which is to be inserted. Here the pointer is the address of last node of the linked list, therefore pointers next is equal to new. So, here is an example to explain the deletion of first node of circular linked list. Consider the following figure. In this figure, the first node containing element 7 is to be deleted. To delete this node, first the pointer variable begin will hold the address of second node, that is begin is equal to begins next. Secondly, the next part of last node will hold the address of second node, which is the address of node containing element 5. Here the address of last node is pointer, therefore pointers next is equal to begin. Similarly, to delete the last node of circular linked list, we need to change the address in next part of second last node. Here, the address of second last node is pointer. Therefore, the next part of node 12 will have address of first node, that is pointers next is equal to begin. To summarize, we have discussed the insertion of new node at the beginning, at the end and at any particular position in one-way linked list. Also, we have discussed the deletion of a node in one-way linked list. Then we have discussed the concept of circular linked list along with insertion and deletion operations. In the next lecture, we will discuss doubly linked list and its operations. So, thank you very much.